Hey everyone, it's Chat here. Today we're tackling the LeetCode problem 238, product of array except self. I'll walk you through how I'd solve this in a coding interview, from understanding the problem and devising a plan, to coding, then testing for errors and evaluating time and space complexity. I'll be using Python to solve this, and I'll think out loud and ask clarifying questions, just like in a real interview scenario. Let's get started. So, to first understand the problem here, I'm given an integer array nums and asked to return an array answer such that answer I is equal to the product of all the elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. And we must write an algorithm that runs in O of n time and without using the division operation. Okay. So if I sum it up, I have nums as an input and I return a list of numbers as output. And we want to return for each index I the product of all the elements of nums except the one in the middle. And we do not, so we would simply use division if we could, because we could just compute the whole product of all the numbers in nums and then divide by the one in the middle so as to remove it. But we cannot do it because we are prevented from using the division operation here. So let me try to better understand the problem through the first example here. So I do have this, and we want to return the answer that would have, okay, this one should have 2 times 3 times 4, right? 6 times 4, 24. For the second one, we should have 1 times 3, 3. 3 times 4, 12. And for this one, we should have 1 times 2, 2, 2 times 4, 8. And then for the last one, we should have 6, right? This is exactly what we do have in the output here. Okay, so I do have a few questions here. So can the numbers be negative? And I do have the answer. They can be negative. One thing that is pretty, so we're given that we can, so as the product of any prefix or suffix of nums is guaranteed to be fit in a 32-bit integer, that does mean that the product of all the numbers is in 32-bit integer. And that is confirmed here in the constraints that the input generated such that answer I is guaranteed to fit in a 32-bit integer. Right. So if I think about the brute force solution here, what I would do is that is exactly what I did here. For each I considered the product of all the other numbers. So so yeah, what I did was pretty simple here. I was here and I computed, so I iterated over the nums once to get this product. And when I had to find the answer for index 1, then I computed the product to the left and to the right, and then I multiplied them together. So I do think we can improve this. So if we consider the time and space, so in terms of space complexity, it is O of 1 because we did not use anything else. While the time complexity here is we are iterating over this nums array almost n times. So it's n square time complexity. But I think we can improve this by having, two arrays, sorry. One can be, prefixes, and the other one can be suffixes. Let's call it prefix. I think it's prefixes, but prefix and suffix. And in here, I could, compute the products from the left. Why am I doing this? Because this way I'm iterating over the array only once. So this gives me 1 times 2, 2. Then and I do not have to actually, compute the product from the beginning. I can just use this one to get the third one. 2 times 3 is 6. 6 times 4 is 24. Right? And then for the suffix part, I can do the same. I'm starting from the end here. So it would be 4, sorry. Copying this. And then 4 times 3 is 12. Then 12 times 2 is 24. And 24 times 1 is 24. So, my bad. So whenever I have to So let's say I had to find the answer for this one, right? What happened here was that 24 is the first one. So we just ignored this one and took the whole right side. And the right part of this can be obtained through the suffix. So if we are at index I, so if we are searching the answer I, then it would be, suffix I plus 1 when it is possible. So I should be, strictly inferior to, I just want to confirm that we at least have, we will have some, edge cases to consider. I will do that a bit later. So I have to be like less than len nums minus 1 so that, I can access I plus 1 without going out of bounds. And so suffix I plus 1 gives me the product of the one to the right, of all the numbers to the right. And I can just multiply this to prefix of I minus 1. And to do this, so this is, answer is like, it is this one. Answer is 1, so answer. So we have to have, let's say, a variable answer that will be equal to 1, and we'll multiply answer by this if we have this condition. And if I will be multiplying it prefix minus 1 if I is strictly superior to 1. Why am I doing this? Because let's consider, for example, this case, right? For 3. For 3, we know that the answer is 8. And to know that, so I take the suffix of this one, so it is 4, and the prefix of this one is 2. 4 times 2 is 8, and that gives us the answer. Yeah, so let me now that we have a solution here, the time and space complexity for this one is much better. We have O of n as, for the space complexity here, as we will have the same number of elements in prefix as in nums, and the same for suffix. But the time complexity is much better now, because we are iterating over nums twice to get prefix and suffix, and then 1/3 time to actually build answer using these two arrays. So it would be O of n here. Let me now carry out the solution by coding it in Python. So I'll be first, iterating over. First of all, let's try to understand. Let's consider the edge cases. So, can nums be empty? If it is empty, we should just return, for example. So if it is empty, that's a problem, right? If there is only one value, that's also a problem, because we have to have a convention. Because when you remove that value, the self value, well, what will be the answer? And now that I look into the constraints, I see that numstat length is at least 2. That means that we at least have 2 elements in num, so we can ignore that. I would ask here to the interviewer if he or she still wants me to consider this case. So let's now implement this. I'm creating this answer suffix prefix I could remove this one actually from here, so that I still have this, because I would just want to compute suffix and prefix first. So let's move with this one. For I in range length of nums, I'm building prefix this way. I mean, yeah, prefix would be maybe it's a better idea if I could, yeah, it's better, I think, if I build it with the right number of elements. So I would put 1 for length of nums. The same goes here. And so now that I do have this prefix and suffix with, you know, the right number of elements, I don't need to. Sorry, my bad. I can do something better. Pretty simple. I could do this with nums 0 for the suffix. No, -1, the last element here, and the first element here for the prefix. And then we are just, adding for I in range 1 to prefix, we are appending the next element. So we do have, for example, here 1 because it is the 1, and we are appending prefix -1, so the last element in prefix, times nums nums I. Does this make sense? So here we have the first element, that is 1, and we are starting from index 1 because we know that it is already included. So 2 times what we had in the prefix. So 2 times 2 is 2. So prefix got 2. Then 3 is taken here, here. And 3 times 2 is 6. So 6 and etc. Okay, so we are building prefix this way. And for I in range 0 to length of nums, yeah, I could just do the same thing here. Yeah, I could do this. I could use the same thing here. And for suffix, we are not appending. So I do have two options here. Either I build a suffix reversed and then I can reverse it back, or I can insert it at the beginning. So I'll be inserting it. I just want to confirm that Python insert. Yeah, so I give the index and then the value. This is what I wanted to confirm. So I would insert 0. At the position, first position, we would suffix 0 times nums of not I, but length nums minus I, and I starts at minus 1. Yeah, this way. So let me confirm that this is the right thing that we're doing. So in suffix, we are inserting, the beginning of the array every single time. So we start with 4 because we took the last value here. Then I'm inserting in there nums, length is 4, 4 minus 1 is 3, 3 minus 1 is 2, so 0, 1, 2, 3 is the right value we are taking here. And then we are multiplying it with what we had, that is 4, 4 3 is 12, and 12 is the result here. Then, and we are repeating it until getting to length nums minus 1, in which case we would have what will happen when length nums, we will not reach length nums. We will be at length nums minus 1. Right? So, oh yeah, it's length nums minus 1, but that is the I that is equal to length nums minus 1. So it becomes minus length nums plus 1 that crosses these things. So we get to the last element here. So yeah, this one works. Now that we do have suffix and prefix built, we can build the answer array that will be empty at the beginning for I in range length nums. I could have named, actually, let me name n length of nums because I'm using it pretty often. So I'm iterating over this array nums, and as I explained here, I'll be filling it up. So for every single one, we create an answer that is equal to 1 if I is strictly superior to 1, then we would multiply answer by prefix I minus 1. Then if I is strictly inferior to length nums minus 1, then we would suffix and we are appending this answer there we go. Let me now just apply this. I've already given the space and time complexity. Let me just test this with a second example given here to make sure there are no errors. So we have nums. What happens first is we initialize these things here. Let me just move this one here. Suffix, prefix, and these ones would have, so if I put prefix here, prefix will have, from this code here, we'll have nums 0, which is nothing else than minus 1. minus 1, and suffix will have nums minus 1, that is the last element in nums, so 3. Then what happens here is that we're going from I between 1 and n minus 1 included, and in prefix we are appending this one, the element that we do have already, the last element we do have there. We are multiplying it with nums I, which is 1, so minus 1 times 1 is 1. Then if I continue this way, 1 times 0 is 0, minus 3 times 0 is 0, minus 3 times 0 is 0. On the other part, we are actually, inserting at the beginning of the array the value we do have at the beginning times n minus 1, so the last element, minus I. So we're starting from here, and we are using them to multiply by the first value. So we started with 3, right? So we're considering minus 3 times 3 is 9. Then 9 times 0 is 0. And now we do end up 0 times 1 is 0. And same here. Now that we do have this, I'm iterating over the length of, nums again. And what I'm doing is defining answer as being the multiplication, the product between the values, the product to the left of all the numbers and the product of all the numbers to the right that are given by prefix and suffix products. And minus 1, prefix minus 1 means for each of these, I'm taking so for example, for this one, I'm taking, as there are no values to the left, as you can see here, because I is equal to 0, this one is not calculated. We just take suffix, which is the one of the next value that is 0. So this one is 0. Then here for 1, I'm taking minus 1 and 0, that is 0. For this one, I'm taking the prefix to the left, 1, suffix to the right, that is 9. That gives us 9. Then for minus 3, I'm getting 0 times 3, 0. And for 3, I just have this prefix, here, that gives me 0. And we can confirm that the answer we do have here is the one that is expected. Let me now run the code to test it. So if I've missed something, there was a syntax error here. This works, and now I can submit this. There's one issue here, actually. I've missed out something. So the test input, the test case that did not work is 0, 0, which outputted 1 on my side. And while the expected, I think I clearly understand what happens here. It's because of the way I define this part. Because if both of them are not, so when we do it, let me check this one. Let's see. So if I have this one here, the prefix is going to be 0, 0. The suffix is going to be 0, 0. The answer is going to be, I start with 1. As we are not satisfied with this one, but also is I strictly superior to 1? It is not the case. It's equal to 0. Is it strictly inferior to 2 minus 1, 1? It's the case. So I get 0. That's right. This one is okay. Yeah, this should work. And on the other hand, oh, my bad. It should be 0, not strictly inferior, superior to 1. I can add this test case actually here, if I'm not wrong. Yes. And we can see here that this should work now. Yes. And if I submit the result now, it works. There we go. And we had a follow-up question here. Can you solve the problem in O1, extra space complexity? The output array does not count as extra space for space complexity analysis. Okay, let me think about this. So actually this comment gives us a hint in a way that we should use the answer from here. Oh, so actually my point here would be to actually, okay, I do have an idea that I will just give you without coding because we lack time here. So what I would do is I will build suffix, only suffix, which I will be using as the answer. Okay, so as I'll be using the same array that I will just be replacing the results, this doesn't count as extra space complexity. For the prefix, I do not need actually to have this array. I can just have a variable that keeps track of all the numbers, the product of all the numbers to the left. So if I am here, it is 1. It is, there's nothing, so it's 1. I mean, it doesn't exist. If I am here, it is equal to 1. If I'm here, it is equal to 2. And now when I have to calculate, compute the answer here, I could just, use a temporary variable to keep what the suffix, had. No, we do not need to keep this suffix here. We just need suffix from the right side, so we can replace, in the answer, this code, and we know that everything before was replaced too. Sorry, let me clearly state my solution. So what I would do is I would iterate over this nums to create a suffix array that I will be using as answer. Once I do have this suffix from here, what I would do is I'll come here and just replace this with 1. Then from the second one, I will keep track of the product before, of all the values that appeared before. So that it will be 1. Why do I do that? Using 1 times the suffix I do have here, 12, I get the answer, that is 12. From here, sorry, I also have it here. Then I move to the right. I keep, I kept track of the product of the values to the left. That is 1 times 2, that is 4. I have this in my temporary variable, and I know 4 is to the right in the suffix. So 4 times 2 is 8. That is the result here. And what I do is, before computing the suffix, the product with the suffix, I just store it in the variable, a temporary variable, and put it in there so that I can access it later on. And yeah, this gives the solution to the follow-up problem. That's it.